Okay. So continuing area. Okay. We're going to dive into all of the other quadrilaterals that we learned. Okay, so again, we're kind of following the way that you've learned these shapes. We're finishing up our two-dimensional shapes in this unit. After this unit, we will be dealing with all three-dimensional stuff. We've learned all of the two-dimensional shapes, and now we're trying to find the area of all of them. Area for a trapezoid. Is this. Obviously, height is pretty self-explanatory. B1 and B2, remember a trapezoid has one pair of parallel lines. Those parallel lines are considered your bases. And just remember the height is always perpendicular to the bases. Okay. So an example of a trapezoid problem. This is going to be a right trapezoid problem. Tell you this angle is 60, this is 10, and this is 6. So let's go through that process we talked about on the last section. Identify the shape, it's a trapezoid. So let's write down the formula. Again, we have it here, but let's write it down again. It doesn't hurt to write it down twice. Alright, what information do we have? We do not have our height, and we only have one of our bases. So we're missing two pieces of information here that we have to find. Remember, our options are Pythagorean theorem, special right triangles, and trig. Okay, I notice a right triangle here. And I notice this is a rectangle. On my right triangle, I notice all I have is the 60-degree angle and a 10. And because I'm a math teacher, I realize that this is a 30, 60, 90 triangle. So I can find my H. And in this case, the H is the long leg, and this part of the triangle is the short leg, and the 10 is my hypotenuse. Okay. If you remember the special right triangle formulas, to get from H to S, you divide by 2. So from H to S is divide by 2, so that makes my S equal to 5. And then to get to S to L, you multiply by square root of 3. L equals 5 square root 3. I also know that this is a rectangle, so I can move this down and make this 6. So the entire bottom part of my trapezoid is 6 plus 5 square root 3. I'm sorry. No, 6 plus 5. Because this part was 5. This part was 5 square root 3. So that's 11. So my base 2 is 11. And my H is 5 square root 3. I apologize. Now I can plug into the formula. B1 is 6. And B2 is 11. For my regular ed kiddos, you could probably just type this into the calculator and get a decimal. For my pre-AP kiddos, I would prefer that you actually simplify this by hand. So I'm going to add these two together. 17. 17 times 5. is 85, and then times 1/2, 42.5 square root 3. Remember, you always leave the square root alone. You multiply everything outside the square roots, and you multiply anything inside the square roots. But you don't combine them when you're leaving it in simplest terms. Again, for my regular kiddos, if you're putting this into the calculator, you should have gotten 73.61. Okay, so there's an example of how you could use special right triangles. Alright. Also, let me point out on this question that you can use trig here. It is possible to get these answers with trig. The problem is for you pre-AP kiddos is if you don't use your special right triangles, you're not going to get the answer in simplest radical form. And that's one thing that's going to be important for some of your tests. You really should be comfortable using simplest radical form. It'll help you out for your more advanced classes later on. Okay. Kites and rhombuses are kind of interesting because even though there are completely different branches of our quadrilateral tree, they actually have the same area formula. And it has to do with the fact that their diagonals were perpendicular. If you remember, in both of these shapes, the diagonals are perpendicular, which created a lot of congruent triangles. So it's kind of coincidence that they do have the exact same area formula. D stands for diagonal. Okay. So an example of a kite, and again this would be true for a rhombus as well. That's 6. This picture is not drawn to scale, but I'm going to say that that angle is 45 degrees. Let's say that this is 9 square root 2. So again, look at your formula. What are you missing? Okay, I don't have either one of my diagonals, so I need to find both of them. The only part I have is this part. So what I need is this section, and once I find that section, because the kite has symmetry, I can just double it. But then I also need this section to add to the 6, and that will get me both of my diagonals. Again, I have a special right triangle here. This is 45, and this is 9 square root 2. If you remember, in a 45, 45, 90, to get from the hypotenuse to a leg, you just divide by square root 2. So 9 square root 2 divided by square root 2 just gives you 9. Because this is a 45, 45, 90, this one is also 9. Okay. Which means my diagonal 1 is 9 plus 9, which is 18. And my diagonal 2 is 6 plus 9, which is 15. So my area is 1/2, 18 times 15, which is 135. Okay. Last example. Okay. I told you this unit has a lot of review in it, so we're also going to be doing some stuff on the coordinate grid. I'm going to go ahead and tell you that this example is going to be harder than most of the questions that you see in your homework, but I just wanted you to see where we could possibly take this. But I don't want to bog you down with math, with a whole bunch of number crunching when we get into the class. So I'm giving you a harder example in your notes. You'll use the same concept in class, but the number crunching will be a little bit easier. So the formula for a rhombus is 1/2 d1 d2. Okay. Here is my rhombus. These are my diagonals. I do not have the lengths of either one of my diagonals. Length on a coordinate grid means distance formula. Always. Okay, I don't know why I have a hard time getting kids to remember that, but length and distance mean the same thing. So anytime you're trying to do length on a coordinate grid, it always means the distance formula. So let's plug these two in for D1. And we've got x1 minus x2, 2 minus negative 3, and 3 minus negative 2. Since we have the new calculators, you can just type that straight into the calculator. You don't have to do it in steps. You can do it exactly the way it's written. I'm going to go ahead and do it by hand just because I don't feel like picking up my calculator. That's going to be 5 squared. That's going to be 5 squared. 25 plus 25 is the square root of 50. And I might have you pre-AP kids do a little bit of rationalizing the radical as well. 5, 10, 5, 2. They get married. They go outside. He stays home in his parents' basement. If you were to type this in your calculator, you would get 7.07. That's D1. D2. This one. Negative 2 minus 1. And positive 2 minus a negative 1. Negative 3 squared, but when you square a negative, it always becomes positive. And that's a positive 3 squared. You get square root of 18. 2, 9, 3, 3. Again, they get married. He stays home. And I am going to have to put this one in the calculator because I don't have it written down from last year. 3 square root 2. If you'd done this on the calculator, you would get 4.24. Now we have enough information to plug into the formula. 5 square root 2 times 3 square root 2. Again, you multiply the stuff on the outside. So we have 3 times 5, which is 15, divided by 2. I'm just going to leave that 15 divided by 2 for a second. Because if you realize, square root of 2 times square root of 2 equals 2, right? The 2's cancel, and all you're left with is 15. Again, you regular ed kiddos in 3rd period, I would expect you fully to use the decimals and just type it in the calculator. When it comes to a test, you can always just type in your answer choices and turn them into decimals anyway. So, alright, that's it for trapezoids, kites, and rhombuses.